Okay, today we're going to be talking about different types of reactions and how we predict the products of a reaction. All right, so our first type of reaction is called a synthesis reaction, and of course, if you think about synthesizing something, you are making something or producing something. So this is a reaction where you're taking two elements and making a compound. All right, so the kind of generalized way we would write this would look like this. You have element A plus element B is going to yield compound AB. All right, super simple. An example might be hydrogen gas plus oxygen gas is going to yield water. And then, of course, we would want to make sure that this equation is balanced because it's not right now. So if I did a 2 there and a 2 there, then my equation would be balanced. Okay, so simple enough, synthesis reaction, right? Let's move on to what we call the decomposition reaction. Decomposition reaction is basically a synthesis reaction backwards, all right? So the generalized formula looks like this. We have compound AB is being decomposed into element A plus element B. All right, so pretty simple. Here is an example. Let's say we have iron oxide, and we want to decompose that into iron plus oxygen. Remember, of course, oxygen is a diatomic molecule, so it would be O2. And then, of course, we would want to make sure that this was balanced, right? So we would do a 2 here and a 4 there and a 3 there, and then we would be balanced. All right, so these two are the easy ones, synthesis, decomposition. They're pretty easy. All right, let's move on to single displacement reaction, or sometimes called a single replacement reaction. All right, and it's called this because what's happening in these reactions is an element that is less reactive is being replaced in a compound that is more reactive. All right, and you'll see what that means. All right, so as you can see, if you look at this chart here, the chart shows you that there are certain metals that are more reactive and, of course, certain metals that are less reactive. So, for example, let's say you had a reaction where you had, say, a silver metal. It's going to be easily replaced by, say, a potassium metal because it is more reactive than the silver metal. All right. So if you're thinking that doesn't really make sense right now, just hold on and it will make sense. Okay. Now the other thing we need to do before we actually do any single displacement or replacement reactions is talk about cations and anions. You should remember that from back in chapter 22. The cation is the positive metal ion in an ionic compound, and the anion is the negative non-metal ion in an ionic compound. Okay, so just so we're all on the same page, I am going to show you that for cations, I'm going to put a little C with a plus sign, so that equals cation. Of course, it's a plus sign because it's a positive charge. And for anion, I'm going to put an A with a negative sign. Of course, that will equal anion because anions have a negative charge. Okay, so this will make sense here in just a second. So let's look at the general equation for a single replacement reaction. So if I have element A plus compound BC, I'm going to get some type of product. All right, so when we look at this, though, we have to consider what type of element is element A. So if element A is a metal, all right, so if it's a metal, then that means that when it switches place with either B or C, it's going to become the cation for the new compound. Okay, so A has to switch with a cation. Well, let's change colors here. B is going to be the cation, and C is the anion. All right, so that means A is going to switch places with B. Okay, and so what we will look like here at the end, so we will have, let's make sure my pen's on, we will have AC plus B. All right, so how did we end up with the AC? So the A and the B are going to switch places. So the A and the B, they have now switched places, okay? And the A is the new cation, and of course the C was always the anion, so it just stays the anion, all right? So again, this is only when you have A as a metal, all right? Now what happens if A is a nonmetal? All right, let's do it again. So here's A plus BC. So what are we going to get if A is a nonmetal? Remember, a nonmetal is a an anion. Okay, so it's going to be the anion. Let me do this, a little anion with a negative sign for A. So that means that the A has to replace the other anion. Well, C is the other anion. Okay, so what we end up with is, excuse me, is BA plus C. So you might be thinking, well, why didn't you do AB? That makes sense. It's be in order. But B, remember, B is the cation, and C was the original anion. All right, so B has to stay in the same place because it is the cation. Okay, remember, because the cation is the first part. It's the metal. It has to be first. And then the anion is the second. So A is the new anion. So now that works out. Okay? Now, this might seem a little bit difficult. Don't worry. Once you start doing these a few times, it'll be second nature to you. And you'll be just fine. Alright, so let's look at some actual examples of single displacement reactions and see what the equation is going to look like. Alright, I'm going to make this small and move it out of the way, and that way I've got some room here. Okay, so let's look at, how about copper plus silver nitrate. Alright, so there's copper plus silver nitrate, and we want to predict what will the product be for this reaction. All right, so first thing we got to do is look at copper. We know that is a metal, so if we look up here, that means that's going to be the cation in the new compound. So that means that copper is going to have to replace silver. All right, so what we end up with is copper nitrate plus silver. See? That's pretty easy, right? So let's try another one. All right. So what if we have bromine, and it's got since bromine is going to be by itself, it's diatomic, so it's got to be Br2 plus potassium iodide. All right. So let's look here. Again, we need to look at bromine because it's the element by itself. What is bromine? Bromine is a nonmetal. All right, so if it's a nonmetal, that means it's going to be the anion in the new compound. So it has to replace the other nonmetal. Okay, so it's going to replace iodine. So now what we end up with is potassium bromide plus iodine. So again, if bromine, because bromine is a nonmetal, that means it's going to replace the nonmetal in the compound in the reactant side. So you get a new compound where bromine and potassium are bonded together and iodine is by itself. Now, are we done with this? Actually, no, because, of course, first of all, iodine is diatomic, so we've got to put the 2 here for iodine. All right, and then we need to make sure this is balanced, and this, of course, is not balanced. We should also check our charges here. Potassium is a +1, bromine is a -1, so we're good to go there, but we do need to balance this. All right, so let's look at this. I've got 2 bromines on the reactant side. I've only got 1 there, so let's put a 2 there. That gives me 2 bromines. It also gives me 2 potassiums, so I'm going to put a 2 there. Now I've got 2 potassiums on each side, and I've got 2 iodines on each side, so now I am balanced. All right? So there you have both an example of single replacement reactions where you have a metal for the element on the reactant side and a non-metal for the element on the reactant side. All right? You might think this is a little bit difficult, but as you do more and more of these, they will become second nature, and it really won't be that bad. All right, now we're going to move on to double displacement or double replacement reactions. In double replacement reactions, or again, double displacement reactions, what we have is 2 compounds in the reactants that are being added together, and we will get 2 new compounds in the product. All right, so these might seem a little bit difficult because these equations tend to be pretty long, but I think that these are actually much easier than the single replacement reactions. So let's look at what the general equation looks like. So we have compound AB plus compound CD, and when we put those together, we're going to get a new product. Now before we think about what the product is, we have to look at these compounds on the reactant side and recognize the cations and the anions. All right, so of course A is going to be the cation for the first compound, and B is the anion. And then in the second compound, C is the cation and D is the anion. All right, so why do we need to know this? Well, for us to be able to determine what the new compounds are in the product side, we want to match up the cation with one compound with the anion on the other compound. So that means that A is going to hook up with D and C is going to hook up with B. And so what we end up with is AD plus CB. All right, let's check and make sure that that's right. We'll change my color here. So A was the cation and D is the anion. And then C is the cation and B is the anion. Okay, so really it's just about, again, making sure that your cation from one compound goes together with your anion from the other compound, and of course the same thing with the other 2 elements in the compounds. Okay, so let's look at some real examples here. Let's say I have silver nitrate plus sodium chloride. All right, what is that going to yield? So here we go again. Silver is my cation, nitrate, polyatomic ion. It's a negative polyatomic ion, so that's the anion. Sodium is the cation, and chlorine is the anion. All right, so silver and chlorine are going to go together, and then sodium and nitrate are going to go together. So what I end up with is silver chloride plus sodium nitrate. All right. Of course, we want to check and make sure that our charges are all correct because these are all ionic compounds, and in this case, everything happens to be either +1 or -1, so it all works out. And since everything is all +1, -1s, this equation is already balanced. All right. Let's do another one. What if I have sodium hydroxide plus hydrochloric acid, or hydrogen chloride? HCl is hydrochloric acid. And what is that going to be? So again, my sodium is the cation, hydroxide, another polyatomic ion, that's the anion. Hydrogen is the cation, and chlorine is the anion. All right. So sodium and chlorine are going to go together, and hydrogen and hydroxide are going to go together. So we end up with sodium chloride plus. Now, if I have an H and I have an OH, that gives me 2 H's and an O. And what do we get with 2 H's and an O? Of course, that is water. All right. And this is actually an example of what happens when you add an acid and a base to each other. They neutralize out and make salt and water. All right, and it just happens to be a double displacement reaction as well. So these are actually really easy in my book. So again, as I said with the single displacement reactions, the more you do them, the more you're going to be able to recognize them and the easier it's going to be. All right, so there it is. Those are the 4 different types of reactions. See ya.